Okay, for this example problem, we have a 20 kilogram girl sliding down a slide. Uh, they tell us what her speed is at the bottom, and we want to know how much energy was lost due to friction. And in part B, we're going to figure out what the coefficient of friction is. But let's start with part A, and let's just draw a picture of this to see what it looks like essentially. So a slide is nothing more than an incline. So if we have an incline here, and they tell us, she's starting up at the top, so let's call that point A, and she's going to slide down here to the bottom. Let's call that point B. And the bottom at point B will make our zero energy line, or zero potential energy line. So what else do we know? We know that this angle here, well, we'll get into what the angle is here. We don't need to worry about that just yet to figure out the energy loss. So, but we do know the height of this slide is 3.2 meters. And that's going to help us find our potential energy. Okay, and that is all we have, correct? Yeah, well, we know, and, sorry, we do know our velocity down here at B. Let's make B red. Our velocity at B is going to be equal to 1.3 meters per second. Okay, that's given. That's right there. Okay, so we can use our workout, negative workout. Uh, it's equal to your change in potential energy plus change in kinetic energy. So your negative workout is equal to this. Uh, and let's back up a second. Let's kind of figure out what our potential energy is at A and what our potential energy at B is. So potential energy at A, we figure out, let's do this under here, potential energy at A that's equal to the mass times the gravity times the height at A. So what's my potential energy? 20 kilogram girl, 20 times 9.81 times 3.2. So potential energy at A is equal to 628 joules. 628 joules. That's the potential energy at A. Kinetic energy at A, she's starting from rest. When she slides down the slide, we're assuming that, she's not getting pushed down the slide and she's not giving herself a push down the slide. So kinetic energy at A, we're assuming the initial velocity is 0 for kinetic energy at A. Potential energy at B is another thing we can say is 0 because we're calling this the 0 line, so the potential energy here has no elevation or no height above that reference line. So potential energy at B is equal to 0. Kinetic energy at B, that can be solved using our formula, mv squared over 2. That velocity is velocity at B. Plug in your numbers and solve. 1.3 for the velocity, 20 for the mass, solve. you get kinetic energy at B is 16.9 joules. 16.9 joules, that's kinetic energy at B. Potential energy at B is 0. Potential energy at A, 628. Kinetic energy at A is 0. So this is the A side of things is the initial, and the B side of things is our final. So we can use this formula to figure out how much work was lost. So our change in potential energy, final minus initial, 0 minus 628, that's a negative 628, plus our change in kinetic energy. What's our change in kinetic energy? Final minus initial, 16 minus 0, 16.9 minus 0, that's 16.9, and that's going to be equal to our workout. And our workout is equal to, workout equals 611 joules. So that's our workout. That's our answer to A. The energy lost to friction was 611 joules. So that takes us to part B. If we have a slide that's angled here at 20 degrees, we can figure out what our coefficient of friction is. And the way we can figure that out is because we know the work. Work is equal to the force times distance. What's the force we're interested in? Friction, the force of friction. That's equal to the work. And in order to find force of friction, we know friction is equal to the coefficient times the force normal. And that's where we've got to figure out what's this force normal that's acting on the girl. What is force normal? And that takes us back to our Newton's laws and determining what the force normal is, because our force weight is acting straight down. That's our force weight. Force weight. That's a terrible color choice. So force weight is down. So we really want to figure out what this weight in the y direction is. We need to figure out this force weight in the y direction. And if we know this here is 20 degrees, then this angle here is 70 degrees. So to find the force weight in the y direction, we will take force weight times the sine of 70 degrees times sine of 70. And that'll get us our weight in the y direction. How do we get weight? mg, mass times gravity. And force weight in the y direction, it's equal to 184 newtons. And that is also what force normal equals. And what was the point of all of that? Well, because we can put it into this equation, force of friction is equal to mu times force normal. Excuse me, the coefficient of kinetic friction times force normal times how far she went. Now, that also leads us to, well, how far did she displace? She displaced down the slide, so we need to figure out the linear hypotenuse of this triangle, okay, if we know 3.2 meters high and we have a 20-degree angle, 20 degrees is going to lead us to getting this hypotenuse using our sine of 20 degrees. Let me clarify that. So the displacement, this length, okay, we're going to use this 20-degree angle here. This 20-degree angle here. The sine of that 20-degree angle is equal to the opposite, 3.2, over the hypotenuse. So let's extend this page and show that down here. The sine of 20 degrees, sine of this 20-degree angle is equal to my opposite side, 3.2 meters, over the hypotenuse, the displacement. Okay, and that's going to help us find the displacement. Do your calculation, cross multiply whatever algebra you're going to use to find the displacement in the x direction, and we'll find that the displacement in the x direction is equal to 9.36 meters. So let's start plugging in all of this information we got in order to find our coefficient of friction. Okay, we can start plugging in answers. This work goes here. Okay, force normal gets plugged in here, and our displacement gets plugged in here. And when we substitute all of our numbers, this is going to look like this. It's going to look like this, and now you are ready to calculate and solve for the coefficient. Do your calculations, you'll find that the coefficient of kinetic friction is equal to 0.355. And that is your answer for part B.